Students, this is your maths book of class 6 for your competitive exams. Our chapter is basic geometrical ideas. In the last class, we learned about line. Today we learn about line segment. What is a line segment? A line segment is a part of a line. Suppose it is a line. If we give arrow marks, then this becomes a line. Now we wrap this, or you can say, suppose this is a part P, Q. Here AB is a line. What is it? AB is a line. AB, this is, we represent it like this. AB is a line. And PQ is a part of this line. AB is a line. And PQ is a part of the line. So PQ is line segment. Now, what is the difference between a line and a line segment? A line has no definite length. It expands infinitely, but a line segment has a definite length. That means we can measure a line segment. Understand? Now we learn about ray. Ray. What is a ray? A ray is a part of a line. Understand? Which extends in one direction infinitely. It is a ray. Suppose this is a line, but this is a ray. It is a part of a line. In this direction, it extends up to infinitely. That means a ray has also no definite length. To represent a ray, we write like this: PQ. PQ is a ray. Which is its endpoint? P is endpoint. P means point. P is endpoint. To represent a ray, we write like this: P is endpoint. Now, what is the name of this ray? Suppose AB. Here we write A, here we write B. Now, what is how we name it? We write like this: BA is a ray. Do you understand? That means we have to write from B. That means here, what is the endpoint? B is the endpoint. Now we learn about the differences between line segment, line and ray. Line segment, it has a definite length. That means a line segment can be measured. Lines, a line cannot be measured. That means it has no definite length. Ray, a ray cannot be measured. That means it has no definite length. In case of line segment, what we have found? It has two endpoints. Okay? A line segment has two endpoints. A line has no endpoints. And ray, it has only one endpoint. To represent a line segment, we use, suppose these line segments AB, we use a bar or BA. Okay, it is. To represent a line, we write like this. Suppose PQ, it is a line. And to represent a ray, we write like this: ST. This is the differences between their notations. Now we learn about intersecting lines. We find here different types of lines now. Intersecting. INTERSECTING. Intersecting lines. NES. We have learned already about lines. Now we are intersecting lines. Which are intersecting lines? The lines which intersect, that means cuts at a point. Okay? These two lines, PQ and ST. PQ and ST are two lines which intersect each other at O. Understand? That means PQ and ST are intersecting lines. That in crossing road, multiple signs, addition signs, etc. are the example of intersecting lines. Okay. Now we learn about parallel lines. Parallel lines. That means the lines, a pair of lines which does not intersect each other. Okay? These are lines, they do not intersect. That means we do not get a common point of these two lines at any direction of the plane. Suppose here this is direction and here this is directions. They do not meet at any point of the plane. Then these lines are known as parallel lines. This LM, ST. These are parallel lines, and this is the symbol. LM is the symbol of line. It is the symbol of parallel, and ST. These are the parallel lines. Now example of parallel lines, which are edges of a book, okay, rail lines, edges of a door, etc., edges of a table, edges of a board, blackboard, etc. are the examples of parallel lines. Do you understand? If you don't understand, please ask me. Okay. Now see concurrent lines. Here we find different types of lines here. CON, CU, regular, ENT. Concurrent lines. What are the concurrent lines? If three or more lines pass through a point, then these are known as concurrent lines. Okay? And the point is known as a point of concurrence. If three or more lines, suppose this is a line. Okay? To represent a line, we can write small letter also like M. M is a line. This is suppose L, M, and suppose this is N. N. L, M, N are three lines and they passes through the point O. Okay? L, M, N are the lines and they passes through the point O. So L, M, N are known as concurrent lines and O is called point of concurrence. Point of concurrence. Point of concurrence. Do you understand clearly? Students, do you understand? Now, see here we get more rays. Suppose this part is a ray, 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 this part is a ray. How many rays here we find? 6 rays. Okay. Then see collinear and non-collinear points. collinear and non-collinear points. Do you understand this clearly? I think you understand this. Collinear and non-collinear points. Collinear and non-collinear points. Collinear points, 3 or more points which lie on a same line, then they are collinear points. Suppose these are the points, 3 or more points. Okay, we take here 3 points. Suppose this is a point P, this is a point Q, and this is a point R. Through these points we can draw a line. So P, Q, R are the collinear points. Collinear points. Okay. Collinear points. That means P, Q are 3 points, and through these points we draw a line. Suppose ST. ST is a line which passes through these points. So these are known as collinear points. Okay. Now you learn about non-collinear points. This is a line. Suppose ST is a line, and these are the points A and B. A, B. Now see, A, B, S, P, Q, R. Through these points, can we draw a line? We cannot. So, S, P, Q, R, A, B are the non-collinear points. Okay? Which are non-collinear because A and B are outside of the line. A, B, P, Q, R are the non-collinear points. And these are the points for you, collinear and non-collinear points. Now we learn about curves. Okay, closed curve, open curve, simple curves. C-U-R-V-S. Curves. What are curves? A curve is a part of a figure which is not drawn with the scale. Suppose this is a curve AB. AB is a curve. Now which are simple curve? Simple curve. Simple curve. A curve which doesn't intersect itself. Okay, this is a curve. It does not intersect itself, but this is a curve which intersect itself. So it is not simple. It is not simple. But this is simple. It is easy or hard? Students? Is it easy or hard? Do you understand clearly? Now see types of curves. Types of curves. Here we get two types of curves. One is open curve and another is closed curve. Open curve and number 2 closed curve. Closed curve. Open curve, that means if a curve start from a point, if a curve start from a point and it is doesn't meet the same point, then it is known as open curve. Suppose this is a curve. In alphabet we can take C, W. It is a curve which start from this point and it does not meet the same point. So it is open curve. And closed curve, it is start from a point, it is open. Suppose it is open. It is open curve and it is suppose closed. It is start from a point and it ends at the same point. So it is closed curves. Okay? Then see polygons. Polygons are closed figure more than 2 sides. And it is made of 9 segments. Polygons. What is a polygon? A polygon is a closed figure, okay, which entirely made up of line segments. We get different of polygons, and polygons are start from triangle. Triangle is the smallest polygon. Then we get quadrilateral. Then we get pentagon. Pentagon, hexagon. Heptagon, octagon, nonagon, decan, etc. are the polygons. It is start from triangle. A triangle is a polygon which made up of 3 sides. Okay? It is a closed figure. It is start from this suppose and see here. PQR. PQR is a polygon. It has how many vertices? Suppose 1, 2 line segment meet at a point, 1 vertex is formed. It is its vertex and this also. How many vertices? 3 vertices. Sides? 3 sides. And angles also? 3 angles. Okay. Now say quadrilateral. Quadrilateral. It is made up of 4 sides. P, Q, R, S. It is a quadrilateral. In case of quadrilateral, we get different types. Suppose rectangle, square, trapezium, etc. Different. Here, how many vertices? 4. 1, 2, 3, 4. And sides also 4. Angles also 4. In case of pentagon, how many sides? 5 sides. How many angles? 5 angles. How many vertices? 5 vertices. Okay. I think you understand this clearly. Now see students, what is a diagonal? Diagonal. When two north adjacent, suppose these are adjacent. After we get Q, so they have a common side. So P and Q are adjacent vertices. If two non-adjacent vertices meet, suppose this and this non-adjacent vertices. When two non-adjacent vertices meet, we get a diagonal. PQ. Sorry, PQ not PR. PR is a diagonal, and similarly joining SQ, we get another SQ. SQ. This is. Students, do you understand my lesson clearly? If you understand my lesson clearly, then for more videos, you can subscribe my channel. Bye bye.